Hello everyone, my name is Mariana Figueroa, Director of the Light and Health Research Center and Professor at the Icahn School of Medicine at Mount Sinai, and I'll be talking about background on lighting and circadian rhythms. So the premise of our work is that circadian rhythms are biological rhythms that repeat at approximately every 24 hours. Circ is about, D is in day. Circadian rhythms, they are generated and regulated by a biological clock in the brain. So in the absence of any external environment, our biological clock will free run. And what that means is that depending on whether you're a diurnal or nocturnal species, your biological clock will run with a period slightly less or slightly longer than 24 hours. For example, a mouse is a nocturnal animal, and it has a period that it's slightly less than 24 hours when they remain in constant darkness. So what you see here on the graph on the right is you see that the black bars are activities. And if they remain in constant darkness, every day they're going to start activity slightly earlier than the day before because their biological clock has a period that is slightly less than 24 hours. In humans, it's the opposite. We have a biological clock that runs with a period on average of 24.2 hours. So if you're in a dark cave for many days, what's going to happen is your activity will start the next day about 10 or 15 minutes later. And that goes, if you stay there for 2 weeks or 3 weeks, eventually night will be day and day will be night because you don't have any external cue that will synchronize you with a 24-hour clock. And that's what light-dark patterns do. When you get up in the morning, you get light, you are resetting your biological clock so that it runs with a period of 24 rather than 24.2 hours. And what that does is maintains you in synchrony with your watch. So the local time on Earth, what it does, it helps you synchronize your internal clock with the external environment. So if you're not synchronized with the 24-hour light-dark pattern, you will suffer from circadian disruption. And circadian disruption will lead to poor sleep and poor performance all the way to more serious maladies such as diabetes, obesity, cardiovascular disease, and even cancer. Now, one of the very well-known circadian rhythms is the sleep-wake cycle. The sleep-wake cycle is influenced by two processes model. One is the circadian clock. So your circadian clock, if you're a diurnal species, will send you an alerting signal during the day and a sleeping signal at night. And what that does, it guarantees that you're awake and alert during the daytime hours and you have a consolidated sleep during the nighttime hours. Now, the sleep-wake cycle is also influenced by the homeostatic system. And what that is, it's a sleep pressure. Think about a sleep reservoir. When you first wake up in the morning, you have no sleep pressure because you just got up. As you accumulate number of hours awake, you accumulate that sleep pressure. So what your biological clock is doing during the day is your biological clock is actually counteracting that sleep pressure that increases over the course of the day. And then at night, your biological clock switches from a daytime mode to a nighttime mode. You have very high sleep pressure and you fall asleep, and then you have a consolidated sleep at night because your biological clock tells you to remain asleep at night. Now, if you suffer from circadian disruption, these two systems, the circadian and the homeostatic systems, will be misaligned, and that misalignment will lead to poor sleep. And we know that poor sleep is associated with a lot of maladies. So let's start a little bit with a definition of sleep. So sleep is a reversible behavioral state of perceptual disengagement from and unresponsiveness to the environment. So you really get disconnected from the environment when you sleep. So it must serve a very important purpose, or else we wouldn't be disconnected from the environment, because we become very vulnerable when we're asleep, and yet we all need sleep, okay? And that is really one of the main questions. Why do we sleep? Why is it that we have to go through this period every day that we're completely disconnected from the environment? It must really serve a great purpose. And we now know from studies that had been done in the past, and much more now with new studies that are coming up, we know that if we don't sleep, we will die. There were studies that were done with puppies, which, I'm not, some of us will feel really bad about it, but there has been studies done with puppies where if they deprive the puppies from sleep for 2 weeks, the puppies die. And they looked at their brain, and there's a lot of degeneration on the brain. So it's a very serious, it really, it kills you if you don't sleep. Now, we're also learning that sleep cleans up the debris in the brain. So what happens is when you're awake during the day, you're generating that debris that it's accumulating in the brain. When you fall asleep at night, especially during deep sleep, you have sort of a cleanup of the brain that helps reduce that accumulation of debris in the brain. And let me tell you that accumulation of debris in the brain has been linked to increased risk for dementia, Alzheimer's disease, and cognitive impairment. So we're learning more and more that sleep is extremely important for health and well-being. We also know that sleep is important for learning and consolidation of memory. So if you learn something in the evening and you sleep at night, you retest it in the morning, you do better. If you stay awake at night and you retest it in the morning, you actually do worse. So the bottom line is pulling an all-nighter to study for an exam is a bad idea because you're not going to consolidate the memory of what you learned on the night before or during that night awake. Now, we also know that the consequences of sleep deprivation is very similar to the consequences of sleep disruption, which is reduced performance, increased risks for diabetes, obesity, and cardiovascular disease. There's an increased risk for depression and mental health issues, increased risk for Alzheimer's disease, and there's also an increased risk for falls. So the fact that you're not sleeping well, you may have less ability to maintain postural control and stability. So what does light have to do with sleep and circadian rhythms? Well, obviously, as I mentioned, light entrains the biological clock to the local time on Earth. So for that, you need a very regular, robust light-dark pattern. It's basically bright days and dark nights. Now, light also has an acute alerting effect on humans. So what it does is increases alertness, similar to a cup of coffee. It impacts hormones. So for example, light at night will suppress the hormone melatonin, which is a hormone that it's linked to nighttime. And you suppress melatonin at night, you will impact health and well-being. It also decreases reaction time, so you react faster. It's similar, again, to a cup of coffee, and it reduces feelings of sleepiness. Now, as I mentioned, light can also provide perceptual cues of the environment, and that will increase postural control and stability. So not only sleep helps with postural control and stability, but also if you give those perceptual cues to the environment, you can actually help people orient themselves in the environment, and that will help with postural control and stability. So lighting for the circadian system, we have been working with a metric that we call circadian light and circadian stimulus. And I'm sure you heard a little bit more, or you will hear a little bit more in some of the other videos that we have in this series. But very briefly, what circadian stimulus is, it takes into account the absolute and the spectral sensitivity of the circadian system. We know that the circadian system has a peak sensitivity at short wavelengths, around 460 nanometers. We know that the circadian system uses all three types of photoreceptors for circadian phototransduction, which is how the retina transduces signals to the biological clock in the brain. So it's the rods, the cones, and the intrinsically photosensitive retinal ganglion cells that all participate in the circadian phototransduction. And we also know that we have a higher sensitivity to light compared to the visual system. So we need more light to be able to activate our biological clock than we need, for example, to see. So what we have been doing is working with a circadian stimulus of 0.3. And what that means is that if you're exposed to a certain light level of a certain spectral power distribution for 1 hour, you will suppress your hormone melatonin at night by 30% if that circadian stimulus is 0.3. So what that tells you is it gives you an idea of what the spectral sensitivity of the biological clock is and how you will respond to that light when it comes to impacting your biological clock in the brain. So the UL 24480 design guideline, what it is proposing is that we deliver during the daytime hours the amount of light equivalent to that after 1 hour exposure, capable of suppressing the production of melatonin at night by at least 30%, and that is a circadian stimulus of 0.3. So what the UL guideline is recommending is that we expose people to that CS of 0.3 for at least 2 hours during the daytime hours, preferably in the morning. But what is most important is that this is a regular exposure. So if you can't do it in the morning, you're doing it in the middle of the day, you continue to do that every day. So you maintain that regular light-dark pattern. In order to avoid glare, UL design guideline also recommend that the luminance of the luminous element of the light source that you're using should not be greater than 8,500 candelas per meter square. Now, ideally, what you want is minimize the direct view of the light source, because that will also help minimize glare. So the questions that we have is, are we getting too much light at night, or are we getting too little light during the day? And I like to focus on the light during the day because I think we talk too much about light at night. And what we're forgetting is that the built environment is becoming dark during the day. And I think we need to improve that, because if we increase the amount of light during the day, you actually become less sensitive to the light at night. And here are graphics of light exposures that we collected for different populations. And you can clearly see that we are being exposed to very little light during the day, and we're not exposed to that much light at night. So the concern here may be, can we increase the amount of daytime light exposures? And we have done some work where we show that if you do increase the amount of light exposure during the day, you actually improve sleep at night. So this is a study that we did with General Service Administration, where we collected data from federal workers, over 120 federal workers in 5 different buildings across the United States. And then we separated the data by those that received the CS of 0.3 or greater in the morning hours, and those that received the CS of less than 0.15, which is considered low level. So it's basically biological darkness if you're being exposed to very low CS. And what we showed was that those that were exposed to high CS, they were taking less time to fall asleep at night, suggesting that they were more synchronized or entrained. They were self-reporting having less depression scores, and they were self-reporting having less sleep disturbances. So more light during the day led to better mood and better sleep at night. We also did a survey during the COVID-19 pandemic, and this was actually a very interesting study, because the idea was that everybody suddenly started working from home. And typically you don't have a lot of light at home. Sometimes you're in the basement or in a closet or in very dark spaces during the daytime hours. You're not going out a lot because everything was shut down. So the question is, how is that impacting measures of sleep, mood, and anxiety? And the hypothesis was that more light during the day equals better sleep and better mood. So we got over 700 responses, and we included in the analysis only those that were working from home or those that did not have work but were staying at home. So what we found is that we looked at light at home and then how much time people spent outdoors, because you get a lot of light outdoors during the day. And you will see in these graphs you have a 50, which is more than 50 is worse, less than 50 is better, except for the last bar, which is in blue, which is the opposite. Greater than 50 is better, less than 50 is worse. So what we found, just summarizing these graphs, were the brighter the environment you were indoors, the better you were sleeping, the less anxiety and less depression you were suffering, and the more positive affect you were having. Outdoors is the more time you were spending outdoors, and more specifically, if you were spending outdoors between 1 and 2 hours, people were actually self-reporting, sleeping better at night, having less anxiety and depression, and better affect. So again, consistent with our GSA study, more light during the day equals better sleep at night, less anxiety, and less depression. So the bottom line is, a summary of these studies is that brighter days equal better nights. So we need to start working on improving the lighted environment. Now, part of what we're working to is, how do you develop personal medicine? And in other words, you have a light meter that collects your light-dark pattern and determines when you need light and when you need to be exposed to light and when you need to remove light to maintain that circadian alignment. So in the meantime, we need to really increase light levels in the built environment. Eventually, in the future, each person will know when to increase their light and will probably have their own specific light source that they can change based on their personal light exposure. So that's where we think the future will be. But one thing we do know, that brighter days do make better nights. So for now, I would like to thank you for your attention, and hope you enjoy this video and the videos to come.